Okay, 5.4, we're talking about triangle midsegment theorem, and hopefully by the end of the video you should be able to prove and use properties of triangle midsegments. So midsegments is the important vocabulary word here, and of course we need to figure out what the definition of a midsegment is. Mid comes from middle, and segment means part of a line. So midsegment is basically, for a triangle, it connects one midpoint of one side to a midpoint of another side. So let me scroll down for a second. Okay, so the midsegment of a triangle is a triangle that joins the midpoints of two sides of a triangle. So let's say I title this triangle, I call this triangle ABC. And I know that D is the midpoint of AB. So I'll show you it's the midpoint by putting tick marks. And let's say I know that this point, point E, is the midpoint of AC, so I'm going to put my tick marks on that line too. And these tick marks, again, I'm putting double tick marks to show you that AC it could be completely different size from AB. They could have different lengths, but E is still the midpoint and D is still the midpoint of their respective sides. So when you connect those two midpoints, that's called a midsegment. So an example of the midsegment would be line segment DE. That's a midsegment of triangle ABC. So why are these important? Well, there's two really cool things that happen with midsegments. So important and so cool that they gave it a theorem, and it's called the triangle midsegment theorem. It's important you put triangle because later on we're going to talk about different polygons that also have midsegments. So this is particular to the triangles. So when we have a triangle and we have a midsegment in the triangle, there's two cool things that happen. First thing that happens is, if you notice, these two lines kind of look parallel, and that's because they are. So the cool thing is that they're going to be parallel. So you can say that midsegment DE is parallel to BC. And if you wanted to put it in words, you could say that the midsegment will always be parallel to the opposite side of the triangle. So DE obviously is parallel to BC and not any of the other sides. So that's one cool thing. And the other cool thing that happens is that DE is going to be exactly half of the length of BC. So DE, the length of DE, is now half of the length of BC. And now notice I dropped my line segments because I'm talking about numbers. So how long DE is half of the length of BC. Oops. Okay, sorry. So DE is, the midsegment is always equals half of the opposite side. Okay, so let's say, for example, that this side length is 5. That means this side length would have to be 10. So pretty cool. Those are the two cool things that happen. I'm going to erase some of these things that happen. Okay, so the second part says that every triangle has 3 midsegments because we have 3 sides, right? So we said that D was the midpoint of AB, and we said E was the midpoint of AC. Let's say we had added another midpoint, F, and that's the midpoint of line segment BC. So now EF is also a midsegment, and this midsegment would be parallel to the opposite side. And it's also going to be half. So let's say this side was 4. That would mean that this whole side would be 8. Similarly, so we did DE, we did EF. Lastly, the last midsegment would be DF. And let's say this one looks a little bit longer. So let's say this one is 8. Then that would mean that its opposite side, AC, would be 16. So AC would equal 16. Last thing I want you to talk about is what happens when we connect all 3 midsegments. Then you're going to have a midsegment triangle. Yay! And we're going to talk in class a little bit more when we start doing our assignment that this midsegment triangle has some cool things that happen with respects to the entire triangle. So that's something to think about. There's a couple different types of problems I can ask you. Let's look at this problem. The first thing I could ask you is for a side length. And you kind of have to read the triangle and see what's happening. So first of all, I know M is a midpoint because of the tick marks. I know P is a midpoint, and I know N is a midpoint. Let's say I asked you for side length JL. So I want to know, how long is side length JL? Well, here's JL. You're going to look at its midsegment, the one that's parallel and opposite. So 36. Okay, sorry. All right, so if I ask you for side length JL, you look at its midsegment, and we know that the midsegment is shorter. So if you take this midsegment and you multiply it by 2, that's going to give you the side length of JL. The opposite side is bigger and it's double. So that means JL is going to be 72 of whatever units, I guess, since they didn't give us anything. Okay, so that's one type of question I could ask you. Another type of question I could ask you is, instead of JL, what if I just want to know about ML? Well, if you notice, ML is half of JL. So ML is going to be half of 72, which is 36. So half of the entire side length is going to be equal to the midsegment. So ML is going to be 36 units. So this one, now we know this one's 36 and we know this one's 36. Cool. So those are the type of questions I could ask you with regards to side length. The other type of question I could ask you is about angles. And since we know angles, we're going to use the fact that we have parallel lines. And we know a lot of things about parallel lines. So let's say I wanted to figure out about, I wanted to know about measure of angle, that's an angle sign, JLN. I wanted to know what that is. Okay, well, first of all, this picture, I could make it way more confusing for you guys, because if you look at this picture, I really only give you one angle measure. Okay, so that should be a big indicator to you. This angle measure is talking about this angle right here. And JLN is this angle right here. So let's look at the lines, that those two angles touch. Angle JLN touches this line of the triangle, this side of the triangle, and this angle touches this midsegment, and those two lines are parallel. And we talked about in chapter 3, we talked about, well, those angles that are on the same side of the transversal would be JL, and on the same side of the line, see how they're both on top of the parallel lines, those are called corresponding angles. So since they're both corresponding angles, that means measure of JLN would also be 102 degrees. So those are the two types of problems I could give you, talking about side length or talking about angles. And we'll delve more in class about, like, this one's obtuse, this one's obtuse, and this one's obtuse. So guess what? These ones are all going to be 102 degrees. We'll talk more about the relationship between the midsegment triangle and the whole triangle in class tomorrow. One more harder question I could give you. This one's harder because I didn't give you measurements. I gave you variables, but I'm still giving you a midsegment because you're connecting one midpoint to another midpoint. So again, the midpoints, the triangle midsegment, theorem says that the smaller part, the midsegment, I don't know why I put smaller, the midsegment equals half of the opposite side. So we can use that formula. The midsegment in this case is n plus 14, and the opposite side is 3n plus 12. So you can use this formula, and if you want to distribute that 1/2, you're more than welcome to, but I like to get rid of my fraction, so I'm going to multiply both sides by 2. So that gets rid of my fraction, and now I'm left with 2n plus 28 equals, this parentheses goes away, 3n plus 12, and then I can solve from there. And then do follow the directions. I didn't give you any directions, so solving for n should be fine. Or you can plug it in and solve for a side length. Whatever I'm asking you guys to do. Last question. You guys are probably saying, wow, this is the easiest thing we've done all chapter. Maybe. Some of you guys might be saying, how can I actually use this? So, I don't know what you guys are going to be when you grow up. Let's say your job when you grow up is to measure the width of this volcano. This is a very pixelated volcano. Okay, so I care about you guys. I don't want you to get injured on your job. So what you guys are going to do, rather than traipsing across this volcano with your ruler or your meter stick, is you're going to actually use the triangle midsegment theorem to actually calculate the width of this volcano. So you guys are going to be the smart people that you are, and you're going to say, all right, let me use what I know. I know I'm at point G, and I've measured out that this is 640 meters safely in the forest. You guys can measure, and then I'm going to measure again another 640 meters, so safely in the forest. So H is now my midpoint. Cool. And then I'm going to go back to G, and I'm going to measure safely in the forest 1,005 meters, make a midpoint marking, and then measure another, again, safe 1,005 meters. And there's that point of the triangle. Sweet. And then I'm going to measure safely, of course, because this is all safely in the forest. And I know that HF
is going to be 750 meters. How can I figure out how long the width, how wide the volcano is? Well, since you've measured out the midpoints, you guys know that this is going to be exactly half of the whole mid-segment, or I'm sorry, the whole opposite side. So all you guys have to do after you've measured a bunch of segments is you just multiply it by 2, and you know that that volcano has to be 1,500 meters, and you didn't have to risk your life or anything. You just had to, you know, measure in the safe forest. So yay for saving your lives, triangle mid-segment theorem. Fun fact of the video, chimpanzees are the only animals that can recognize themselves in mirrors, besides, of course, ourselves. So we've talked about triangle mid-segment. That's the only thing we're talking about. Yeah, have fun with that.